bit hot and sweaty, but there we go. So apologies. Listen, I hope you like the space. This is our presentation area on the 4th floor. What we didn't realize was that when we bought this building, I don't know, a year ago, that part of the development was we've got to develop all 5 floors. So that's the gymnasium, the cafeterias, the bars, you name it, as well as floors for lots and lots of techies. So we're well on the way with that here at Acorn, a Liverpool company, three centres in Liverpool. Always been quite quiet about who we are, but we're a lot bigger now, so you'll hear about us a bit. So thank you all very much for coming, first of all, and thanks to .NET Liverpool for putting this event on. Xena who's going to give us an interesting speech about, or talk and demonstration about .NET and legacy systems, and I'm sure quite a few of us in the room have come face to face with that kind of challenge. So hopefully, I'm sure we will get some really interesting insights today. So that's all ready. Just want to say welcome. Hope you've all know where the toilets are. Had some pizza, beers, Coca-Cola. Just handing over to Josh. Thank you very much for putting this on.
Cheers, mate. Okay. We got Samson. Are these? Is this up to your live stream?
Yeah. It's on the auto. What do we do?
Just on the auto loop thing.
Yep. If you go back to the screen, like push your mouse to the screen, that one. No, not that one. That one. Yes.
Yeah.
Yep, that one.
Sweet. Yeah, all good.
If you.
It works.
Yeah, all good.
It works.
Oh,
All good.
perfect.
Yeah. So again, thanks. Big thanks to Acorn. Again, we've been between venues for a while now. We end up at like 1 for 2 months, skipping around, and it's a lot of organisation. So big shout out. Thanks so much for the space and letting us put this on today. So really appreciate it. Just going to talk about some of our sponsors. So we've got Hyperloop with us today. Where's our resident Hyperloop over there? Alex in the corner. So speak to him if you're looking for roles. We have a JetBrains giveaway. So there should be a QR code somewhere. Has that been floated around? If not, take a picture for this. You just got to enter your email. We'll do a draw at the end, and someone wins a year-long JetBrains license, which is worth a lot of money. So it's definitely worth going at. And these are the things you can get from it. Got more sponsors. So actually, Josh and Samson started a venture, Plan My Holiday. Take a look at that. It's personalized travel experience. If you're interested, speak to Josh Samson at the end. We also have a store now, so you can buy your own .NET Liverpool t-shirt. And Josh and Samson also working with the community. We've set up like a little consultancy powered by the community. So if you're in need of some consultancy help, whatever it is, whatever problem, big or small, speak to Samson or Josh at the end about that. And just to let you know, we're going to be taking some pictures throughout. So if you don't want to be on socials, come let me know. I'll make sure that you're not on any of the pictures. And I'm going to hand over to Ksenia to talk about modernizing a legacy .NET platform. So over to you. I'll give
Thank
you a clicker.
you. I'll just need to
switch.
I'll just need to somehow manage to bring back my slides. Indeed. Let's see. Samson, can you help me? I just need to this one, and that's it. Right. Okay, great. Just need back my mouse. Okay. Finally, all the technical issues are solved. Good evening, everyone. Nice to see all of you here. I'm Ksenia. I'm going to talk about modernizing a legacy .NET platform tonight without stopping delivery, which sounds very nice and promising if you put it on a website. In reality, it's more like replacing an engine on a plane that is flying, and people complain that the Wi-Fi is getting slow. So this is the reality. In this talk, I will not show you beautiful greenfield architecture because this is not where most of us are living. Just out of curiosity, is anyone here working on a platform that is more than 10 years old? Okay. 15 years old? Okay. 20? I don't know. Okay. Yeah, so most of us live somewhere between a WCF endpoint, store procedure, IIS, shared utility library written by someone who left in 2016, and release train that doesn't care about us and has to deliver to the customers. So this talk is not a step-by-step tutorial how to convert WCF to gRPC. There will be no code samples, partly because of NDA, and partly because if I showed you actual code samples, some of you might need a therapy session afterwards. So what I want to share instead is the decision-making model, how we scope the work, what was included, what was scoped out, what previous modernization attempts taught us, what we refused to do this time, and obviously where AI helped with all of that. So let's get started. Yay. So I come from Aristocrat, and this story is from Aristocrat. This is a highly regulated, high-throughput environment. We serve major customers in lottery, betting, and gaming. For this reason, there won't be actual code samples, as I don't want you guys to win a Powerball or a Mega Million. Sorry for that. And that matters because modernization of this type of environment is not just technical preference. It's not about we would like to use a new framework because we're getting sad. It's about auditability, compliance, stability, operational risks, and keeping the delivering changes safely for the customers. Our platform is 15 years old. It is heavily Microsoft-based, .NET, SQL Server, IIS, WCF, and a long history of business changes embedded in different layers, and also database logic, and a little bit of Visual Basic in the basement. Serves millions of users, processes very high transaction volume. Obviously, we deal with money. And we measure success not by how shiny the architecture looks like, but by whether production keeps behaving correctly, and especially when we change the plumbing underneath it. There's also an important NDA line here. I can talk about patterns, decisions, and lessons, but I will not use actual service names, and everything will be simplified. The scars, however, are emotionally accurate. So here is the thesis of the talk. Modernization is not primarily a framework upgrade. The dangerous version of such projects starts with a sentence, we just need to move from .NET 8 to .NET 10, from .NET Framework to .NET Core. And that sentence should trigger the same survival instinct as this will be a small change, no impact, database impact should be minimal, very easy task. I believe you guys have been through this thing. Legacy code is not dead. I like to call it the revenue with trauma. It contains customer-specific behavior, some historical edge cases, operational expectations. Sometimes the bugs became contractual obligations because production has depended on them for years. So the useful question is not how we move everything, but the question becomes which behavior should we move first, and how do we prove that it stayed the same? And that question changed the whole project and moved us away from technology first planning towards behavior first planning. We were not trying to win architecture beauty contest. We were trying to move critical behavior into modern runtime without surprising customers, operators, regulators, and product or support. Our platform did not start as a microservices platform. It grew over many years, as many successful systems do. the systems do not stay small. They collect more customers, features, exceptions, integrations, bad jobs, dashboards, operational scripts. We had the old world, WCF, .NET Framework, IIS, stored procedures, shared libraries, and some of that code was perfectly reasonable when it was written. Some of it is still perfectly reasonable, and some of it is a type of thing which you can understand after staring it a couple of days and maybe crying for some help. And we also had the new world, microservices, modern .NET services, containers, deployment, new infrastructure patterns, observability, and more explicit ownership boundaries. And both worlds live together. And this is the key point, because modernization did not happen in the empty room. We did not switch the platform during the night, rewrite everything, turn it back on. I wish we did, but that's not what happened. We had to move behavior while the system kept serving production. Teams kept delivering features and customers kept expecting the platform to be stable. So that is me in Texas. The sole purpose I went to Texas is to be able to say that is not my first rodeo. Because I actually went to rodeo, and now I legitimately can say that. So we've been through more than 3 waves, but these are the main waves of modernization. Each one taught us something. The first wave was to move from monolith to microservices and so on. And that started years ago. It changed the system, introduced additional capabilities, decoupling, created some clear service boundaries, and move away from one giant deployment mindset. The second wave was API and front-end modernization, but we don't care about front-end here, right? The business need was very real. Customer-facing APIs and UI patterns needed to look more modern. There was a pressure around old pages, large payloads, too many parameters, and an aging front-end stack that we kept losing RFPs because of that. The third wave is the latest one, moving critical .NET Framework and WCF-based capabilities towards modern .NET. And this is the story that I will spend most time of it. But the reason that I mentioned the earlier waves is not just to show off, look how much modernization we did. The reason is that those waves taught us what not to repeat. They taught us that modernization fails when it tries to solve every historical problem at once. And they also taught us that rollout is not a side quest. You do not have a new architecture until the old one is not retired. So let's talk about the first one briefly, about microservices. They helped a lot. I'm not here to pretend that microservices never happened and were collective hallucination. I don't know how many of you have microservices in their system right now. No one. Just a few. Okay. So they gave us clear boundaries in some areas. They made some scaling patterns easier. They helped reduce some deployment coupling. They gave also the teams sense of ownership and specific capabilities, but they also invoiced us. The invoice arrived as a rollout complexity, double maintenance, duplicated logic, and a lot of integration testing that we did not budget it for. One of the big lessons was that development is not done when the new service is built, but when the old path is retired. That sounds obvious, but it's incredibly easy to ignore. When a team builds a new service, everyone is happy. There's a new arrow on the architecture diagram. Everyone celebrates, but then only some customers want to live on it. The rest stay on the old system. Some customers are cautious. And then you end up maintaining 2 systems, and these systems coexist. The old path still gets fixed. The new path gets fixed. Product keeps adding features. And suddenly, The modernization team is not just modernizing, but backporting and forward-porting changes and reconciling between them and trying to remember how do we even start it and how it ends. We had a shadow mode, which is very safe, but also expensive. We were able to reconcile all the new behavior that kept changing because the changes kept coming to the old implementation. It gives you control how the rollout happens. It lets you create a rollback if the rollout is not successful, but the shadow mode stops being a temporary safety mechanism and becomes a long-running subscription and double maintenance. While some customers were still on the old path, the platform did not freeze, product kept delivering, fixes kept coming, customer-specific changes kept arriving. Every reasonable change made the legacy path move again, and that is why the shampoo image works so well here. The team is genuinely rinsing the legacy away. We're making progress, but while we are not looking, somebody adds more legitimate bottle of shampoo. From outside, it looks like modernization team is never finishing. From inside, it looks like finish line is being regenerated constantly. And the lesson was not that the other teams should stop delivering. The lesson was that rollout and contribution rules had to be part of the engineering plan. This becomes the engineering challenge. The old path needed a date after which it stopped accepting the new behavior, and customers needed a mandatory route onto the new one. Also, what we found during this reconciliation phase, we found lots of issues. If you compare the monolith system with the new shiny system and expect it to reconcile completely, sounds like it should work. What happens in fact is like you keep finding old issues, which again sounds like a win, but sometimes it creates a lot of difficulties. Every difference creates a difficult question. Is the new implementation wrong? Or is the old system historically wrong and production adapted to it and it's been running for 10 years like that? And that question attracts everyone. Product wants to improve behavior. Engineers want to fix properly. Architects want a redesign. And everyone has an opinion on that, which doesn't help to move faster. Meanwhile, the original migration goal was much simpler. Move the existing behavior safely. At some point, an issue has been in production for so long that it becomes grade 2 listed, may be ugly, may make no sense, but customers may depend on it. Operational processes may assume it, and removing it now requires a separate decision. I'm not saying that such bugs should not be fixed. I'm saying that each such decision delayed the delivery and attracted lots of stakeholders. So the fixing of these bugs shouldn't be smuggled into runtime migration. For the migration, preserve the behavior, record the defect, decide separately whether the protected landmark should be renovated or demolished. For the second wave, which is API facelift, the business driver was very easy to understand. Market expectations had moved. Customers expected linear APIs, not old ASPX pages. So the idea was, let us modernize the front end and the API interface. And front end was a separate team. Make it cleaner, more REST-like, linear payloads, modern UI. And this is where the fun begins. Because product looked at it and said, now we can do things properly. Let's bring all the best practices and redesign the flow. Improve experience, introduce better capabilities. Architecture on the other side said, don't touch architecture. Do not introduce any new services. This is a pure facelift. Do not touch our system. And the backend team stood in the middle, aging, waiting for some decisions to be made. Because if one old page call returns a massive payload and the new API is lean, how the front end is supposed to consume all the rest of the data? And if the calls represent different responsibilities, which probably they are, how do we not introduce new services? And you're also not allowed to keep the giant payload. So congratulations, you're in architecture escape room. On top of that, front-end modernization has its own truth. And I quote, the user wants a button. Well, they don't care about the orchestration layer. They need a button, and preferably with a spinner to make everyone happy. So until we design a button, you wait. We did make some progress, though. We modernized login, multi-factor authentication, registration-related flows. We built a configurable MFA module. We avoided performance degradation, even though one old API call became multiple backend calls. But it was slower and way more frustrating for everyone than it needed to be, because front-end and backend were both discovering the target shape at the same time. So the lesson is simple. Do not run front-end and backend modernization in parallel, unless the contract and UX are already defined. If the front-end design is still moving, the backend API will move. If the backend architecture is constrained, the front-end will feel constrained. If product sees a modernization budget and wants to redesign the whole system, which they naturally will, none of it will hold and work together. And everyone is not wrong, everyone is right. But it means you're no longer doing a facelift, you're doing a full product redesign, API redesign, architecture redesign in the same project, which was never the goal. So this slide is entire project meeting in one image. Product wants full reconstruction. Architecture approves a Botox, maybe brow lift, nothing else. Front-end wants eyes and mouth to work independently. And backend just stays in the middle, aging and losing their mind. So we went for an API facelift and ended up in architecture therapy. And another lesson is that performance expectations shouldn't come as part of the deal. They need to be explicit, because at some point, the expectation was not that we not introduce the performance degradation, but also some improvements by replacing one API call with several ones. So that phrase, while you're there, I believe it should be banned, illegal. But I believe that you guys have heard this phrase multiple times. So performance improvement can absolutely be part of the migration goal, but then it is a scope item. It needs some analysis, design, time, acceptance criteria. And yeah, it's like asking a dentist to replace your hip, which might be a valid request, just completely justified, just different procedure, different price, and different risks. So migration cannot treat performance as a complementary upgrade. Now we arrive at the latest wave, moving critical .NET framework and WCF-based capabilities towards modern .NET. The reason, again, was kind of obvious. Having critical parts of the system on legacy runtime and WCF creates certain limitations, affects scalability, deployment patterns, long-term supportability, and the ability to reuse the modern platform investments we already had. But rewriting every application and every endpoint was not feasible for one team. Did I mention that it was all about one team? Yes. Also, we had learned enough from previous waves to know that a heroic rewrite is usually not ending well. So the project motto became same business behavior, less legacy runtime panic. Sounds very boring intentionally, but boring is how you get to production. Exciting migrations are the ones people mention in incident reviews. And this time, we wrote down what we're not doing, and we stick to it, powered by No as a service. I believe you guys heard. If you didn't, that's an actual thing. Feel free to use. We were not redesigning product behavior. We were not solving old bugs unless they block the parity. We were not changing the database layer. We were not promising performance miracles. We're not optimizing every old decision. We were not starting an optional customer rollout that could live forever. That was, I think the air conditioner started working. That was the survival. Every modernization project attracts extra scope because everybody has a legitimate complaint, and while you're there, you may as well replace the hip. Product has improvements, engineers have refactors, architects have a target state dreams. QA also has an opinion. Support has operational pain. All of them are valid, but validity is not the same as scope. For this project, the goal was to move selected behavior to modern.NET, preserve caller visible behavior, keep the database contract stable, validate parity, and retire, eventually, the migrated legacy path. So that clarity made later decisions easier. We had 3 options on the table. First one, full modernization. Let's rewrite everything. It was clean as target state. You move the full selected service boundaries, retire the legacy path, and end up with the least long-term maintenance. The downside, obviously, considering this one team, is how expensive it is and how slow it will take, how much time it will take to see first results. Option B was 90/10 hybrid transition. The idea was to move only the highest load flows first across several domains, because a small subset of operations represented most of the traffic. Basically 10% of the endpoints is 90% of traffic. That gives the fastest traffic relief, but it creates dual runtime governance. You now have to keep old and new runtime aligned, shared libraries, routing, parity, ownership, and release coordination, and it all becomes a project of its own. The option C was selective endpoint modernization. It takes the highest value behaviors and expands them only when necessary to keep technical cohesion. Doesn't try to move everything, does not create a long-lived shared library hybrid platform, moves a coherent slice and retires that slice. And the lesson here is every option is painful. The mature thing is not to find the painless option, but to choose the pain you can govern. So we picked the option C, obviously. And the numbers helped us make the decision. The selected domain surface had hundreds of operations. A much smaller subset represented the highest load baseline. But we did not simply take the smallest possible list, because tiny random slices are dangerous. And if you move only one endpoint but leave the tightly coupled business logic behind, you create split ownership. The new service needs some logic. The old service still own the logic. And product changes arrive, and now two teams have to make the same business change in 2 places. And everyone pretends that this is temporary until it appears on the next year's roadmap. So the selection principle was cohesion, starting with the high value, high load behavior, then include the directly coupled operations, needed to avoid code duplication, which left us with, instead of 10% originally, with 15% of the endpoints. And we left a significant isolated tail behind on purpose until there is a business case to move it. That gave us a scope that we can chew, the scope that we can commit, and coherent enough to own. And coherent is safe. The execution model used a stronger fig pattern. In simple terms, callers can be routed to the legacy path or to the modern path based on configuration and the rollout rules. This gives us safety, control over rollout, rollback plan, and if we need sort of a reconciliation. You can enable gradually, you can test in lower environments, you can control customer rollout, fallback without redeploying everything if something goes wrong, which in case of our customers, it becomes a big deal. But here's the important part. Strong graphic is not the same as shadow mode forever. Feature flags give you control, but retirement will give you eventually the value. The flag that never expires is not a safety mechanism. It is a museum exhibit. It says, here lies a decision we were too afraid to take. So the rollout design had to include the retirement design as well. How do we enable? When do we enable? Who signs off? What evidence do we need? What happens if parity fails? How long do we support dual contribution? When does the old path stop receiving changes? When is it disabled? Those are not admin questions, but architecture questions, because if you do not answer them, your architecture will be whatever happens accidentally after the release. One of the biggest improvements in the latest wave compared to previous ones was governance. And I know governance is not the sexiest word at the developer conference. Sounds like someone's about to open a spreadsheet. So I tried to fix it the best I could. Anyway, governance traffic routes is a traffic rules. Without it, everyone may be acting reasonably, but the system still crashes. So before the feature is ready, the migration team owns the source changes and the plan. During that time, other teams contribute to the old system, and it's on modernization team to port the changes that were introduced. During controlled rollout, both old and new paths may exist. So contribution rules need to be explicit. After rollout, the modern path becomes the target, and the legacy path enters retirement. So we defined a clear dual contribution window of one release, which in our case is 1 month, during which, yes, other teams supposed to introduce changes to both places, old and new. And after that, the target source becomes the new service only. And we start the retirement of the old service at the same time. If nobody owns retirement, everybody will own maintenance. Now, talking about AI, unlike previous waves, AI was important and joined us in the party. It was important, but not in the way conference hype sometimes suggests. It's not like we opened Claude and said, please modernize our platform and wake us up when it ends. Didn't exactly work like that. AI helped with work that was repetitive, evidence heavy, painfully slow for humans, like discovering dependencies, tracing caller behavior, comparing old and new logic, drafting contract mappings, generating and implementing test scenarios. The useful mental mode was AI accelerates the evidence, but humans approve the decisions. AI can produce a migration plan. Engineers still decide whether the plan is acceptable. If AI produces a contract mapping, the engineers are still accountable to check semantics, naming, error handling, and compatibility. And AI can compare old and new behavior, but QA team still decides whether the evidence is good enough for release. So AI changed the economics of the project, especially in the investigation and repeatable migration tasks, did not fully remove the judgment or the humans in the loop. So this is the migration factory that we built. It's not mindless automation, but it is repeatable with expected outputs at each step. And the first step is context. What is the current behavior? Who calls this service? Which dependencies are involved? Which shared libraries, caches, configuration sources, store procedures, and operational behavior matter? This is the first and very important step. And the second is the plan. What is in scope? What is not in scope? Which dependencies do we keep? Which we replace? Which we wrap and split? And again, humans reviewed the suggested plan. The third one was the contract. How does the old WCF map to the modern gRPC contract that we agreed to use? How do we preserve request context, errors, nullability, timestamps, enums, and sensitive data behavior? And then there is the build implementation phase, where the AI implemented the selected behavior according to the approved plan. And then there is obviously the review. And on the review phase, we designed it in a way that the agent doesn't know anything about anything around, except it compares the old and the new. Nothing around it, just signs off the parity. It registers the findings and provides human for review. It can fix it or adjust the plan or fix the implementation. And then there is rollout. How do we enable it safely, observe, fallback if needed, and then retire when the evidence is good enough? And the output of each step was not only code and specific artifacts that we designed to have, and those can be reviewed. Obviously, people were heavily involved. And this slide is deliberately simple because this is one of the most important points that I'm strongly advocating for in each of my talks. I strongly believe that humans will not be fully replaced, that AI is a tool, and we need to own the consequences and give the judgment to humans and accountability as well. So all of the developers in my teams were fully aware that they are accountable for the output. There is no way to say that AI wrote it, so I don't know. You deal with it. And the same goes for the QAs, obviously. Agents can execute the task, but they need to be instructed, they need to be controlled, watched over, and people own the gates. The agent can discover some coupling, but a person decides whether this scope is acceptable. Agent can draft a plan, but a person resolves the business and architecture questions. We designed agent in a way that it outputs the question for human to answer and then implement. Agent can implement some candidate, but a person reviews, merges, or rejects it. An agent can collect the evidence, but QAs are responsible to sign off and review. And this matters because I've heard different stories in different events, but this is how we do it. Sometimes the old system is wrong, sometimes the new implementation is wrong, sometimes both are wrong, but production learned how to survive. Sometimes what looks like a bug is actually a customer-specific behavior that nobody documented. That is why we treated AI as acceleration, but not authority. Now let's talk a bit about the QAs. The unit tests are useful. I'm not starting a fight over unit tests. They tell us that a method, a class, or component behaves correctly, but they don't answer the question that mattered the most, whether the behavior remains the same when the real request travels through the caller, through the routing, service logic, database, and back. That is why the QA workflow started before test automation and before the new implementation was treated as complete. At first, they created a behavior context artifact from the existing code. I know I called it PRD. I'm not entirely comfortable with this term anymore. So it's not exactly product documentation. It is a bit of product, a bit of tech documentation. It captures service capabilities, use cases, flows, rules, validations, error handling, but it also captures the embedded infrastructure, like whether we're using the Kafka, we're using some cache infrastructure, and so on. QA reviewed this document for correctness and for understanding, completeness, and only then they approved as a source of truth. Second, QA compared that approved behavior source is covered by the development implementation plan, which is also the artifact stored for everyone to see. And if at that point, the plan doesn't cover all the behavior described in the PRD, then there is a discussion between developer and QA team. And the work does not move forward. And third, the approved behavior became deterministic Gherkin scenarios. Now I know most of people know what BDD is, but if someone doesn't know what BDD is, maybe. So behavior-driven development. So you create these scenarios that describe business language, the expected behavior, and then you implement the code behind. It is close, but it is more business language, I would say. The scenarios look so that a business person can understand when they read it. DDD? Yeah, that's a different. Yeah, that's a different one. Yeah, BDD is behavior-driven development. So first we have this context document, then we have a review, and then we have the scenarios generated by the agent, which again, AI can help you generate, but only QA people know how we write scenarios here, what are the best practices, and they can review. And some scenarios might not be for automation and still remain manual. So they decide whether this is a manual or to be automated, or whether it's a performance or load testing, or we don't need to test it at all. This decision is still human. For the scenario selected for automation, the implementation, again, is done by the agent, using all our best practices and reviewed by humans. The tests had to be deterministic, and caller level tests remained agnostic to which route the feature flag points to. So basically, you run the build with the old implementation. If it's green, you point to the new one. You run the build, it's supposed to be green again. The tests were run, peer-reviewed, approved, then maintained as part of the regression in the release candidate environment, UAT environment, and not in production because we can't run tests in production. This is the confidence. This is how we build the QA process. So unit tests prove that some pieces work, but BDD helps you preserve the behavior. This is the slide I wish every migration project had at the start. What we don't do, we do not redesign checkout during migration. We do not touch database layer. We do not promise faster performance while changing the runtime. We do not move perfect architecture into a migration whose success criterion is behavioral compatibility. We do not let rollout drift. Basically, we define that each customer is supposed to go live within 2 releases, and then the old path is retired. So that's, in a way, we force them to accept the change. Each of those may be a good idea, but a good idea in the wrong scope is still a delivery risk. So we used a simple rule: modernization can be boring, and boring means that business behavior stays stable while the runtime, transport, and ownership changes. Boring means QA can reason about expected outcomes. Boring means support knows what changed, and it means that rollback is possible. So it's not about lack of ambition, it's about getting to the production eventually for everyone. So it all sounds nice. And at that point, I thought, well, I cannot share it without sharing some of the issues that we faced. So let's talk about those. We found it hard for AI to implement infrastructure behavior. So we found multiple issues, and one specific issue was related to the caching behavior. The old system had a fallback from cache to database when the cache values were outdated or insufficient, and in the new implementation, it didn't, which led us to a bug that looked like this. The game was disabled, but because the cache wasn't yet updated, the user was able to play the game, something like that. The validation rule was migrated, the data access layer was migrated, but the old cache infrastructure had this specific behavior of falling back to database that the new one didn't. So each use case that we faced like that helped us to improve the agent workflow so that we avoid to face the same issues. But yeah, this was one of the things that we found. Another thing was when the validation was executed, the new service returned the error, but the caller did not process the error correctly, which again resulted in a behavior when the player wasn't supposed to be able to play, he was able actually to play. So on a service level, the behavior was preserved, but the control flow consequence of this rule wasn't preserved. So we had a couple of issues like that when the errors were mapped differently, swallowed by some adapters, or locked without being converted into a blocking result. Again, the service could make the right decision, but the caller still did the wrong thing. That was one of the common issues that we faced. So for that reason, we again adjusted the agent and enforced the QA to validate such cases. Another thing was that we did not specifically target to verify the database behavior because we didn't touch it. But in some cases, we saw that even when the response is fully the same, the structure of the response parity is sufficient, the test must still verify that the new rows, the new records were created in the database. So in that case, the shopping cart response was fine, but the shopping cart ID wasn't the new one, was some old one. So if you focus on that, the response parity gives you a green build, but in fact the behavior wasn't fully correct. So for create operations, we emphasize to validate the database layer specifically, not just the response, even though that introduced additional scope of tests. And certainly there were not just black and white, there were kind of gray use cases. For example, we found that the agent implemented a more specific error code that looked more informative than the old one, which seems like a nice thing to keep. So we verified that the caller behavior was preserved, and we just let it be. We also found that some of the error logs were logged on a different level in the monolith part, on the info level, not on the error level. So again, such cases we preserved in the new implementation. Therefore, each situation is different. Even though we try to avoid changing the behavior, we still kept the common sense with us. So if you take something from this talk, this is the slide. What worked for us was the cohesive slices. And by the way, it also helps you save some tokens. If you migrate one endpoint, we saw the average cost was about 1,000 credits. If you migrate 5 cohesive endpoints, it does not become 5,000. It becomes 20-30% increase. So that allows you also to save on tokens if this is something that you worry about. Feature flags with fallback work. You can safely roll back, you can test easily. This is something that I will take to the next modernization wave with me. This is something I can recommend. Plan for the rollout when you start the project. Think about the end goal, plan for the rollout. This becomes the engineering activity. This cannot be fully admin issue here. Focus on the parity first QA and leave everything else aside. Create a repeatable migration factory. If you use AI, then use that one, but keep the human approval gates and instruct the people that they are the gatekeepers. They are accountable for the end result. What did not work was a Big Bang rewrite, obviously. A voluntary adoption, meaning that we convince each customer and we wait till they accept, or other teams that they need to accept the new changes. Changing front end and back end at the same time, it's a very bad idea. I will not recommend it. Accepting additional refactors while you are there, even if they make sense. Shadow mode, that is very safe, but without expiration date, becomes a maintenance issue. And the last but not the least, architecture purity battles. If you don't move the database layer, can you call it microservices? Maybe not. Maybe not. But that's not the end target state. This is just one of the milestones that we're doing. And as you can see, the boring governance decisions actually made a difference and brought value for the team and for the project overall. So it's not only about technical decisions, it's also about the governance. And 5 rules. Start with the behavior, not with the technology. Technology is the thing you're changing. Behavior should be preserved. And behavior is what customers care about and the business cares about. Second point, pick some cohesive slices, not tiny random slices, not rewriting everything. Pick something that is coupled and can be moved together. A small migration can still be dangerous, but if you keep the scope contained, you can do it and put it to production. Third, make rollout mandatory for everyone and define retirement at the start. Inform everyone. This is how we do it. This will be retired by this date. You just have to accept it. If the old part has no retirement plan, you're just adding more complexity, just decorating it. Fourth point, treat parity evidence as a product deliverable. It is not just QA paperwork, it's the proof that customers cannot notice the change, which we want them, in this case, not to notice the change. And the last one, use AI with some governance on top of it. It can help you accelerate the evidence, but do not delegate judgment to it. It can make discovery, planning, mapping, investigation, testing feel easier and faster, but the gates still need to belong to the engineers, to the QAs, to product owners, depending on the gate. The rules, not exactly glamorous, but they come from several waves and from the trenches, and I can definitely recommend sticking to those. Okay, the last one. The samurai has no destination, just the path. I don't know, it's like a Japanese Bushido reference. You cannot complete modernization. You can just move on to the next one, because while you were doing the previous one, the system evolves. So I'm not going to pretend that 15-year-old platform reaches its perfect final state. The business keeps moving and technology keeps moving, and today's modern service eventually becomes somebody else's legacy. The goal is to finish each slice, retire what is replaced, carry the evidence, do the lessons learned, make the next modernization safer than the last one. Thank you, everyone.
Question for Mike, so
Oh,
if
okay.
anyone's got any
Yeah.
questions?
I didn't enable it. I don't know if anyone heard me.
Oh yeah, he's got mic as well. Oh, I got it.
Hi.
Thank you for the good job. I was gonna ask, this is my first time hearing about the BDD. So, for DDD, it's done maybe using UML, test-driven development, your normal unit test language, maybe in C# or any unit test unit. So I was gonna ask, the BDD, is it just a plain document that describe each module, their behavior, how it's expected to behave, like a technical or maybe specification documents? So I was just trying to understand if that is the case, or maybe it's just a different language that is needed to be, to design the behavior of the system.
Yeah, should I enable it? I don't know.
Oh, you're fine.
Okay. So it is actually a plain English. It doesn't require you to know any language, and it's human readable. Moreover, it's not only human readable, it's like business people readable. That's the goal. It sounds like an actual sentence. Okay, some people write the user stories like that. Let's say, given I am standing here, when I press the button, the screen opens. That is BDD scenario. That is it.
Got code, run the code.
Yes.
Connected in the keywords.
So when you look at it, you see just the text, but you can, but it's the text, each text is mapped to the methods that implements the code.
Cool.
So you can trace it back to the original requirement, and you can also travel to the code way and, there and back. And why it's great is because business people can create these scenarios. QA people that do not hold the knowledge of creating the code can create those scenarios. They can understand it, they can debug it. So this is, for example, we're using the SpecFlow framework, which is very easy, and most of our tests. What?
It's not retired.
It is, but we're still. That's another modernization. So next time we'll talk about it. Yeah.
The other question, I saw you mentioned you stated gRPC,
Yeah.
but I'm not sure I heard you mention it. So I was just going to confirm how did you how was it used in the system? Was it used to, communicate between two microservices or
Yes.
two or more or it is used to communicate from the front end to the back end? Because I have a reservation to use maybe gRPC to communicate within microservices alone. And I've
Yes.
had, some back and forth with other developers about talking, oh, using it for back end to front end, which I really don't found, because if you had used it, you'd have need to make some changes to the front end. So I just wanted to make mention of that.
Fix the contract.
What's it?
Use the side from the version 1, we're using one protocol, and this is, I prepared the new contract with new protocol. And you see, I'm ready to implement from one side, for example, on packet, I implement WCF or gRPC the same time, the same priority, and say, okay, when you're ready, you may compare your front end from WCF, whatever, into gRPC. You got to always step, fix the contract, and try to implement before you may move forward from, for example, from front end.
We stick to the approach that you mentioned. We have gRPC for internal communication, and with the front end, we just keep the HTTP.
Okay, thank you.
Okay. So you mentioned on your slide that you had unit tests as well, and you migrated to BDD. Isn't that just really integration tests, really, on that
We
side?
kept the unit tests, obviously. It's just
Well,
that
yeah,
unit
unit
tests.
test, integration test are different. On the
Yeah.
slide, it said unit test.
Yeah,
So
BDD obviously is more of an integration, more higher level test. However, we also used BDD scenarios for the service level tests on the API and level tests. So you can use that both from a gateway layer to the and on the service level as well. In fact, we have both. Unit tests were not removed. Unit tests are there. It's just when AI generates the unit test based on the code that it created, you can never be sure that it validates the actual behavior. So it does give you value, but my main point was that it's not all. It does not give you the confidence level enough to proceed to roll out.
for the favor integration over unit
Yeah.
test. Yeah, sorry.
Okay, well done. You've done so much today. Um, what I want to ask is, you said you moved from monolith to microservices. Are there considerations you had in mind when you guys moved from monolith to microservices, like uh, team size, manageability, and maybe moving to cloud and so on? And another question I would like to ask is, in your team, do you have QA who manages the tests, the testing, or the same backend developers handle testing as an implementing TDD or
So
BDD?
yeah, let me answer the second one first. So I have manual QAs and QA automation in each team that I manage, and both QA and QA automation contribute to the test automation. Sometimes we do get developers involved in the implementation part, not the scenario creation exactly. That never ends well, to be honest. The way they see the implementation is not exactly how QA sees them, but we do get them involved. But basically, yeah, this is the QA domain, QA automation domain. As for the microservices, so that was a very important revolutionary period, moving on from a monolith to microservices. We do use the domain-driven design. We define the main entities and define some domains around it. We picked some slices that we moved to microservices. In fact, those microservices right now do not exactly look like microservices anymore because they get huge. But that was because I come from infrastructure and core part of Aristocrat. So we set the best practices. We shared the template that everyone can use. We defined the best practices for everyone to use. So now one of the goals that we had, that new code, new features delivered by other teams are not added to the monolith. And that goal was achieved 100%. Unless they absolutely have to, they do not grow the legacy code. They create new capabilities using microservices approach. So that was achieved. We also considered, because when we move to cloud, there is the regulation aspect here. Some of the customers not exactly accepting us to host in the cloud. So that is some of the gaming operators. They want us to preserve on-premise. So that created for us additional cost that was budgeted. But still, that opened the possibilities to scale according to the expected load, independent ownership, faster delivery life cycle. So I would say that microservices experience was successful and is, in fact. So right now, most of the code, because we keep measuring how much code is added to the legacy and how much is added to the microservices always have the most part of the code.
Okay.
I was just curious when you were talking about the taking a cohesive slice and feature flagging it and developing the. You mentioned that new features would come in that would have to be supported in both branches.
Yes.
Did you have the same team developing both branches or different teams? And was that a deliberate decision, or was it just?
So, like I said, our teams, we don't work with the customers unless it's something very major. The other teams that we have, which is 50 teams, let's say, they work with the customers. So this agreement was with them for a specific period of time, which is one release, 1 month in our case, that if they absolutely have to introduce the new behavior, and it happens so that they have to do it in the service that we are migrated, but not rolled out yet, then they have to do the changes both in old and new system, but new still takes over. New still becomes the first source of truth, but as a backup plan, they also do those in the old one, just because at that point of time, we're not yet fully rolled out to all customers, and we have to have a backup plan. So they become also invested in our backup plan, which they were not happy about, but it happens. You know, when you have a due date for that, you say it's just 1 month, it works. Yeah.
I'm interested in how you manage the inventory. So like each of those like gates that you specified, how did you coordinate all of that? Was it just a spreadsheet on someone's machine, or what was the communication like on that?
So at the beginning of the project, we agreed that we will be using a repository for the documents. We are not using the SharePoint or Confluence or anything else or internal wiki page. We agreed that all the documents will be in repository optimized for AI, basically MD files. If AI is involved at any stage, you may as well start from the MD files and not with any other type of document. So we created, we have a shared repository where we share skills, agents, instructions, and everything. And we also have a repository per service, which also has the docs folder. And that includes all the artifacts generated on the way. So for QAs, that includes their context document, their scenarios, the implementation file, obviously. For the devs, that include the dependencies analysis, like the discovery phase, that is the first one, the implementation plan, the review artifact that is generated when the review is done, and what else? And the final protocol that sums up all the events that happened. If the plan was changed, if any review comments were introduced, then you can review it to understand the history. And that's already proved very popular with other teams that work with the services that we develop, because they have the whole history, and that is not always the case, especially with the technical projects.
Thank you. I'd love a copy of these slides as well.
I think, can we share the slides on the meetup group
Yeah.
after? Is that okay? Amazing.
Sure.
Chris?
Cheers. Hi. I thought a key theme of your talk was around maintaining scope creep. Obviously, people hear modernization, a bunch of stakeholders hear a bunch of different things. Apart from sharing a link to this talk, have you got any tips on how to manage like stakeholder
scope?
expectations and scope creep?
Yeah. I'm still learning to do that, and that is a big part of my role. So that is probably why it's been all over the talk, because it's a pain point. I think some of the ways to manage the scope is the documentation as well. We start and we document some decisions that we make, and sometimes these decisions is not what we're doing, like I mentioned, but the things that we're not doing, and this becomes a source of truth that you can refer people to. But when we scope the project and we provide the estimations, we agree that we're not doing performance this time, that we're not introducing new capabilities, that we're not fixing something that you just found, which also helps with the project management specifically. If you're dealing with the project management, you just always put a price tag on it. Say, okay, we can do that, but that means the delivery timeline moves half a year ahead. And that also helps sometimes. But yeah, having like a shared document that everyone can look into, and that leaves less room for interpretation because of the multiple stakeholders that we're dealing with. Still, people read more or less the same. So if it's written, it helps.
Talk show host.
Just again going back to like the whole BDD points, where the BDD and the framework, did it exist before or after migration? Was it like a situation where you had the entire current business functionality drafted out, had the entire test plan for it, and then you basically tried to do the migration and had a, like as a regression kit, or was it like develop basically was it like a new introduction during the migration process?
No, it wasn't. It wasn't new. We used it on top of other test approach that we have, but here it became part, like a mandatory phase that you cannot skip, and it's not like extra work. It's not a parallel activity. It's like a phase that you should implement and get a sign off. Before that, it exists in parallel. Like some teams did manual QA, some teams did automation, some did both. Here in this type of project, we still did some manual tests, obviously, but most of it were automation, and most of it were BDD automation. So that was the main difference, but people were familiar with that because we have thousands collection of tests running. It's just that here it wasn't a voluntary thing, I would say. It was mandatory and the main test tool. That was the difference.
Great talk, by the way. Really, really enjoyed it. Thank you. I'm curious about your team's use of AI tooling, and whether you sort of hung your hat on one particular set of tools and you stuck with that because it helped with consistency of migration and the whole approach, and what challenges you found and how you address them in terms of um, having small cohesive piece of work you could do and use AI to generate code and or whatever, and then balance that against the time taken to check it. You know, as you say, the human in the loop for you is
Yeah.
very, very important, but you don't want to not leverage the power
Yeah.
of AI. So there's a sweet spot you need to find. So I'm just curious about those two things.
Yeah. So the we used because, like I said, we're Microsoft based, so we use Copilot heavily. By the time I'm talking with you, we also have Claude, so we would have to adapt it, but it's the factory will remain more or less the same. So most of it was done using Copilot. We created a shared repository with the instructions and skills and agents. And the big part of the job for people were to define those, because there wasn't like anything that we could use from the beginning. There was GitHub Copilot modernization tool that didn't really bring us any value. So we had to think by ourselves. What we found difficult, and I believe you guys are familiar, is the amount of hallucination that AI introduced when we just ask it, just copy this to here. So that's why we instructed it very specifically how we want to do it. We gave the actual references to the existing implementation. Like, for example, if you need to implement the cache infrastructure, look here. This is the reference. If you are creating the app settings file, look here. Do not invent anything. Use the patterns that we have, and that actually helped a lot with the level of code produced. People do review those. Still, we find issues. Like, for example, we had an issue that AI completely ignored our folder structure, so it created a shared BL component in in one endpoint file that is called by another. So our architects were not happy about that. It worked, but it didn't look correct. So obviously it's a learning curve. You face some issue and you adapt and you change it. It's also a learning curve for people, because people were not familiar with the tools to this extent and they were resistant to the tools. But that's why we emphasize that you are still valuable, you're still accountable. We want you to sign off on the solution. We want your opinion, and we want all of you to work on that and give something from your perspective to the agent, from your perspective to the tool. So the balance, I believe, is it's each company decides for them. I've heard people shipping straight to production what AI produces. We cannot afford that. The risk, because of the domain that we're operating in, is just a bit too much. We can lose our license, we can get fines, we can get in trouble, really. So for us, as of now, with the current models that we have on the market and which might change, this is how we work. If the models become smart enough that we see that the reviews do not bring value, maybe we will revisit the approach. But as of now, we see value in these review gates and human gates.
Thank you.
Just quick question. Towards the Copilot and the repository rules you've created, do you guys have like a not ballpoint measurement, but sort of like estimate on actual time or resources that it's basically saved the company in general? Like towards the post period of the whole rules and repository creation and creating that infrastructure for the for Copilot, has there been like significant um benefit to the company, basically?
Yeah, because first of all, because we are, my teams are sort of pioneers. We created that. We spent time there. and we are sharing it to others, and we expect others to use those. So they will not spend time on it. Like if some team need to run some modernization, they can select our set of skills, and they won't spend time on it. We spent some time on it. I'm not saying that we didn't. Still, the overall timeline was 30% on average, because we calculated 30% average we saved on this project. So it was justified if you think about it. Even though we spent significant time defining those agents and skills and creating the repository, still we saved 30% compared to manual labor, so to say. Thank you.
Thank you.
Now we're doing the name picker.
Yes, we're nearly finished. We've just got the raffle to go.
me
So if you've
just,
scanned the QR code, we've got a JetBrain license to give away. For those of you who want to keep up to date as well, we've got a newsletter on the .NET Liverpool website, .NETLiverpool.com.